Now let's go ahead and get to the next example on how to derive CDF functions from PDF functions and use them to calculate probabilities. So let's reconsider example 3.2, where X is the time between customer arrivals to a service window measured in minutes, and the PDF function was given to us when X values are non-negative. And we want to derive the cumulative distribution function here. So same as what we learned here, if you are deriving the CDF function from a given PDF function, you got to integrate from the beginning point of the range of that random variable to X. So let's go ahead and do it here. Integrating from 0, the beginning of the range here, to X on the PDF function, you will get to 1 minus e2 negative 0.5 times X. And that is your CDF function for random variable X. Now, from here, you can use the CDF function to calculate probabilities and avoid integration. You essentially have a closed form formula that you can use to calculate probabilities. Find the probability that the time between two customer arrivals is more than 5 minutes. Well, if you're calculating probability of X more than 5 minutes, you know that it's equal to 1 minus probability of X less than 5 minutes. And this is the CDF function. So what you can do is 1 minus CDF at 0.5, which will be 1 minus e2 negative 0.5 times 5. Right? If you do the math here, you will see that it's e2 negative 2.5, which I believe is equal to 0.082. Double check that. So that's how you calculate probabilities using the CDF. And part C of this problem is asking us to use the cumulative distribution function to derive PDF, probability density function. Well, this is just to remind you that, hey, we use the PDF function here to find the CDF. Now, if you want to do it the opposite way, use the CDF to find the PDF, you would have to take the derivative. So PDF is equal to derivative of CDF with respect to X. And that means, taking the derivative with respect to X of the CDF function, and that will give you PDF function that you had originally.